Okay, so let's have a format for the presentation. We will keep it limited to 10 minutes.
Okay.
And then after that, we can have a discussion session on the PPT.
Okay. So, I hope my screen is visible.
Yes, yes, yeah.
Okay. Okay. So, uh, as the format you have suggested, starting from introduction to inferencing, I have made a brief presentation. Okay. So, hello everyone. My name is Ajiket, and about my background, I am a mechanical engineering graduate from COEP University, which is in Pune. And after that, after my bachelor's, I've also done my MTech in mechanics and design from 19 to 21. So, and currently I work in the research and development wing for Whirlpool Corporation, Pune. And these are my brief research interests: mechatronics, semiconductors, and robotics, of course. So, this is a brief background about me. Uh, about the setup, what I had made is, as you can see, this is a top view of the setup. From a hardware perspective, I'll just explain what the new hardware and what new things, like the changes which will have changes from our setups. So this camera is viewing the my pick and place whistle with from the side, and then I have a gripper camera also installed and in the front of the gripper. So in this image, you may see that there are a lot of wires in the top image, but I have in the view of the cameras, I have tried to maintain that the camera does not see the wires. So even if this image shows cameras, if you can see in the robot view, as you can see, this two wires will be visible. But again, these wires will I've tried to make not these two wires into my grid-based data set. What I'll record. So none of my the this whistle which will be coming into the box will be placed anywhere near the wires. This I have tried to maintain while I record the data sets. Okay. Then, while recording the data sets, what I have tried is I've made a simple 3 by 3 grid, and in one of the grids, I've kept the bowl location. And the objective is to pick up the whistle from which is placed in any of these grids, and then put the whistle back into the bowl. Here, I have tried key. Yes, these episodes are less and not as suggested to the 50 plus episodes, but I wanted to go through the complete loop. That is the reason uh, for a start, I used only 14 episodes for uh, as a total. And in this 14 episodes, I have tried key 1 to 8 parts will be used for training, and the ninth will be for the testing purpose. So that was my objective. Then these uh, these are my replace parts of the episodes. So in the grids which I shown earlier, there were okay. I'll just play. In the grids which I shown earlier, I collected the samples at random in that 3 by 3 grid. So I just made a random sampling of those grids, and then I started to pick up the like collect the data sets. This and this is my view of replaying the episodes. Okay. Okay. Then we will come to the training part after collecting the data sets. So as you can see, the I of those 14 episodes, the training hardware was used was RunPod 4090, RTX 4090. And these are my typical the training metrics which I could understand. So basically, batch size was 8. Initially, in the first part of the training, I encountered that CUDA error, but in the uh, uh, repo, it is mentioned कि reduce the batch size. Then I reduced it to 2, and then I again increased it to 8, and somehow it again got trained for a batch size of 8. So steps are less as my episodes are also less, because I wanted to understand key first if it is able to uh, at least go to the location and understand where the object is kept. So relatively smaller training time, only approx 25 minutes because the dataset itself was low. And after the training part, these were the outcomes, the major outcomes, I will say, from the training part. So my L1 loss was 0.1254, and my KL divergence loss came out to be 0.01. And I trained for around 2.2 epochs of the scenario. Okay. And after training, Dr. Rajat, I'm into issues and I'm still trying to debug those issues. So, like as time, like in this meeting, as uh, I'll not go through this debug thing because in the Discord we are already discussing and trying to debug thing. But just FYI, I'm getting this rerun error, and I'm trying to debug this with the help what the Discord group and
Okay.
some things. Yes. So
One suggestion I had, Ajiket, is
yes,
let me, yeah, if you go to that diagram where you have drawn the six grids,
yes.
yeah, the nine grids.
Huh.
So you have placed the ball in the eight grids for the training, right?
Hmm.
So for testing purpose, I think you should try both the cases, not just in the ninth grid, but also in
In
the first two eight grids.
in group testing and out
Yeah,
of
in
group
group and
testing.
out of group, both of
Yes.
these should be tried.
Yes.
And one metric we can see is in the ACT paper, they have trained till the loss goes down to 0.04. So it is 10 raised to minus 2, that order of magnitude.
Hmm. Hmm.
Because we are not running a validation test, uh, we are in the dark. We don't know when to stop, right?
Hmm.
So
Hmm.
that is one metric which I use to get a sense of, okay, when should I stop the training?
Hmm.
Because if it's too less, then it will not learn it properly. If it's too high, it might overfit to the specific eight locations which you have trained on.
Correct.
So that sweet spot has to be identified.
Huh. Yes.
Um, and I still feel that the wire should not be there in the camera. Even
Even though
though,
the robot does not
yeah,
see.
yeah, it is. It should be clean somehow. Mm, you
Okay.
can try it, see how the inference works, but
Hmm.
I think my intuition tells me that it should not be there over there.
Acha, okay. I thought if the camera is not able to see
Yeah.
the wires, it should be okay. But
No, no, it's
huh,
no, no. Yeah, yeah, that is true. That makes
hmm,
sense. But even in the camera, there are two wires which are.
huh, huh, huh,
That is what I was
hmm,
trying to.
hmm,
But then let's see. I mean, if the wires are static throughout the whole course of the episode,
hmm,
it shouldn't really affect the inference.
yes, that is also a very valid point. Yes.
Okay, this is a good start, Ajiket. You can go ahead and
Okay.
test it out and then post in Discord.
ठीक
Uh,
है. Sure. Sure. Fine. I'll post in Discord, and
yeah, yeah, yeah. Sure, sure. Okay.
ठीक है. These were the current state, and you also asked if uh, like the next steps and the ideal next steps uh, which we can say.
Yeah.
So
Have you thought about that? The next steps for this?
Right. So one, of course, is the inferencing debug, which I have to take on priority to,
Okay.
uh, and then these are some of the things which I would like to explore in the like after I fix this
Right, right.
debugging part.
Mm-hmm.
The cutting fruits with a knife. Like these will be different use cases. For example, in
Interesting.
the uh, because while the teleoperating part I tried with the like the knife part, but we
Mm-hmm.
realized ki the gripper is not that in like good enough to hold a knife like a arm would hold it.
Correct, correct. Yeah.
So we
Uh,
may need to modify the gripper design. But like these are long terms after
sure, sure,
the
sure, sure. Definitely.
inferencing part is definitely sorted out.
Yeah, yeah, yeah. This is good, Ajiket. You can maybe cutting fruits with a knife might be tough with this
Hmm.
because uh, it needs to go down also with that force. It can do like translation movements forward and backward, but
Right.
it has to go down also and increase apply some force. I'm
Yes.
not sure if that will work out.
Maybe cutting a banana.
Yeah, yeah, maybe that something soft which can be easily cut. I would like to share this one so that all of you get a sense of what all type of things can be done using the SO-101. So Lerobo launched this hackathon last year, 2025, and people from all over the world participated. Let me just share my screen. Yeah, so I came across some very interesting use cases over here. So this one got the first prize. So this is very interesting. I'll just show you what it does.
I am Le Chef, your personal sandwich maker. The chef understands your order through speech to text and LLM reasoning. The latter holds the different tasks through function calling and answers with text to speech.
Hello, can you make me a sandwich with ham and cheese, please?
Your ham and cheese sandwich is ready. We enhanced the S0-100 robotic arm by adding rail-based movement, inspired by
So
factory production.
the first question that all of you might be having is how it is understanding the text query, right? Because ACT does not take any query, any text query. It is simply conditioned on the proprioceptive, its own joint angles and the images.
Demonstrate this, we built a sandwich.
So this team, what they did is they took the ACT architecture as the base policy, and they have a figure in which they showed how they modified it.
Plastic kitchen robots. Our solution offers an affordable.
So it's like a subway, basically whatever you get in a subway where they mix and match some ingredients and
With our
prepare a
conditioned
sandwich.
ACT, one model can be asked to
Can you
perform
share the link on the chat?
this
Yeah, just a second. Yeah.
by modifying the model's inputs and modifying
Yeah,
the
so
data sets.
see here,
One
if you look
model
at
can be asked to
just a
perform
second,
different
they will show that,
This-
yeah, this one. So same ACT architecture they have used. The only difference they have made is they have some specific task inputs. Like, let's say there are five tasks, okay? And you represent the task as a one hot vector. So take salad is 00010. Then maybe take cheese will be 00100. And then this will also be passed as a input to the encoder. So basically, during inferring, what is happening is the robot is looking at not just the images from the camera and its own state, but it is also looking at the one hot vector which has come inside. And then the actions are conditioned on the observations, the state, and the one hot encoder, like whatever that vector is. So it's a very crude way of taking into account the query. They don't use any transformer, like they don't use any VLM, which is used in vision language action models where query is taken into account. But because they don't generalize the queries, they have only maybe four or five queries, and for every query there is a specific task being performed. they do a crude approach, but it's like modifying the existing act architecture to take into account user inputs, which I found to be very interesting. And I don't think this is very hard to do. Already the code is there in Hugging Face. We just need to add one more input to the transformer encoder. That's it. And then depending on the input in our trainings, we have to the whatever task our model performs should be dependent on the input which is given to the encoder. So for example, if we are saying take salad, then the the human who is doing the demonstrations or recording episodes should only take salad during those demonstrations. So that has to be taken care of on the demonstration side. But on the architectural side, I think this is fairly straightforward to implement. And there are a lot of variations possible if we sit down and think, okay, fine, is there a better way of taking this into account? This is one modification they did.
Implies modifying the model's inputs and modifying the dataset structure. We use an MS-17 stepper motor.
Second modification they did was to make the S0-101 move across the rail.
Encoder controlled by an MKS driver over our S485
This I have not fully understood.
to track the robot's position on the rail.
But they have a mechanism to track the robot's position on the rail.
We also designed and 3D printed parts to build the rail and mount the arm onto it. We updated the Le Robo code base to handle the new motor
But is
class.
that done more deterministically or is it through active?
Yeah. So I think what's happening is, first of all, the query analysis is completely deterministic. It is they have a one hot vector which is represented as each query. This rail position is something which I think the output of the ACT model is not just your actions of the robot, but also which position of the rail. So, for example, if someone says pick a salad, then or pick bread, then the arm should move more towards the right side of whatever is there in the screen. So at every time step, previously in our lectures, we were seeing that there are 6 degrees of freedom, so 6 actions, right? But in this case, there are 7 outputs instead of 6. And the seventh is the location of the robot on the rail where it lies. I am very interested to understand this in detail more than the rail part, is that they have conditioned it on the text query, which I found to be very
Conditioned
interesting.
at T, one model can be asked to
I,
perform
I, I
different
did not
scientific
think that was
tasks.
possible,
This
this one.
implies
This I really liked.
Hi,
And
sorting medicine.
yeah, we can go through some others also. I'll show you some others, but okay, let's move on with the presentations. So these are some of the future directions which you can be motivated by. I think they give a very nice perspective on how people all over the world are thinking. So there are 50 which have been shortlisted. Okay, let's go ahead. I think Rajesh, you are ready to
Yeah,
present.
exactly.
Yeah.
Okay. One second. Let me. Okay. So yeah, my name is Preetham. I'm a software developer at Walmart here in Washington State, Seattle. And yeah, I've been really intrigued about how Gen AI and physical AI converge. So that's why I took this course, and that was my aim to get hands-on training. So firstly, thanks, um, Dr. Rajat, on this one. Why this project matters is, of course, the curriculum is like in hands-on. So I was really intrigued by that, and how my knowledge in Gen AI and this comes converge together. That's what something I was more looking forward to learn. So I got the foundational pieces. Definitely, there's a lot to learn here on. So end-to-end pipeline view on what I did, like we have done, right? I've noted the simple steps on identifying the port, calibrating the robot, teleoperating it, then recording data sets, and training and then inference. So mostly these were the 8 steps that I followed. On the physical setup, I have the robotic arm. So I have a leader arm right besides me on my left, and then I'll show you a video. On my right, I have uh, this was the first camera in that arm, and then my iPhone camera and um, the robot camera. So 3 camera setup. For training, so teleoperating was pretty easy. I was figuring out on my small desk how do I do it. So I kept another desk on the right hand side. So even that was a little difficult for me because I had to see there and the table is on the other side. So I had to really catch the object and make sure it's working. But I managed to do that. I collected about 20 samples. I wanted to collect more. But yeah, this was my setup, and this is the teleoperating part where I'm just showing a free frames in the video. Um, so that's about collecting data. 3 cameras, 20 data sets. And then my compute infrastructure, I used RunPod 4090 GPU. And I realized when I increased the number of steps, so I did it with 5K first. So 20 gigs RAM was fine, but the output was not really good. So I increased the number of steps. I changed the frequency where I should save. I think I also tried with different batch size. But since the training takes a lot of time for 50K steps, I kind of went with this model because I was getting some inference that was working on the on a few in a few setup. So that was about inference. And locally, I was inferencing on my MacBook. And like you saw, I have the hardware with me. So there is some videos I've attached when I was training it and seeing some loss as well. So it was around, it's not captured here, but the loss was around 0.05 when I saw the with 50,000 steps. Um, so this is capturing the detail and then inference in action. So this was one of the inferences. So I called in my 3 years old when I was doing the inference, and in like 3 or 4 tries, I found a spot where it was working. So that's the video I captured, and you can see it now. So that's talking about in distribution part, and then out of distribution there were many. So I saw a lot of failures as well while it's trying to grab the object, but it's right in front of it, but it's not able to grab it. And I also believe there was some, if you see, there were some shadows in this video. So I thought this one I was doing at night in my room, and I saw shadows also play a role. So I need better playground when I'm doing inference and also training. So next step is like when I do any training or inferences, I want the setup to be really clear. But yeah, this may be out of distribution. That's why I didn't catch it. I kept the ball right far away as well. But even the object, I kept it right below the nose of this robot. So which I had not done in the training part. Challenges, like there were some challenges on the space that I have right now, but there were also glitches in the vision. My iPhone camera did not always work. Sometimes it just stops the inference in between only. So I had to figure a few things. Even calibration sometimes was messy, so I had to restart my calibration. It did not move that well, so I did a lot of calibration exercise and made sure it's working as expected. And like you see, there is distribution out of distribution failure. So giving it more data set, coming up with a more strategic training data set. I think that is something I did not invest time on, but I want to do that as well. Next step, collect more diverse demonstrations, evaluate the robustness across different positions, and then add the evaluation metrics. So that is something I want to work on. One of the experiments, Dr. Rajat, you also mentioned, I had also talked about it in the last lecture, where I give a speech and then, it should kind of organize my table for me. Keeping the pen in the pen holder, taking out any trash paper and putting it in the trash bin besides the table, something like that. So this is something I want to build out of this someday. Hopefully with this push and learning that I've got, it'll help me, and also what you shared today. So I'll do some more digging and try to come up with some experimentation around that. But yeah, any questions and some acknowledgements. Thank you for the bootcamp, and then of course the contributors around the community who have helped build this awesome product as well as the libraries that are in place.
Yeah, this is excellent, Preetham. I actually saw your video which you shared of your daughter and showed it to some colleagues also. So all of us watched it together. It was nice to see that. And yeah, I mean, overall, I think it's good. And as you said, you need to be more strategic with the data collection, I feel. And like a general question or something which all of us should focus on is how to improve the generalization of this policy. Uh, I could see in Discord that I think Rajesh was trying out different configurations with parameters. So I'm interested to see.
Yeah, I have done about 10 experiments, different types.
Okay, okay. Yeah, your observations will be helpful for us as a group because I think many of you have now managed the initial setup and know how the pipeline is working overall. But I think we should really improve the robustness of the policy and try to see how we can improve the generalization because that is finally very important. Somehow it should be robust enough that at least 80% in distribution and out of distribution, even if it's 60, 70, it's fine. But yeah, as you said, the shadows, that was a very interesting observation. I thought that will make a difference if it's captured in the day or night.
Yeah, it was trying to like go against the shadow and grab that shadow. So I thought
Okay.
it was doing that.
Oh, interesting. Uh,
Yeah,
yeah.
one other on the side note, like there's a funny story to this, the whole cohort that I'm doing. So I'm based out of US and it's nighttime when I take this. So my wife was expecting that I will build something that's going to fold her clothes. So maybe someday I'll be able to do
So
that.
on that note, actually, I'll share this. We it's possible to do this with the current hardware that we have. If you look at this team, they won the second prize here. And
Medicine box. In this hackathon, we're teaching the Layrova S0-100 arm to help with everyday precision tasks, folding a t-shirt and sorting medicines into medicine boxes for the elderly. We recorded 50 episodes of holding the t-shirt with bimanual S0-100 arm.
So the thing is, you need two S0-101 arms for this. There are two leader and two followers. So there you can see the episodes being recorded for the two follower arms on the left.
Oh, that's nice. But they have to work in tandem, right? Like both the arms.
I'm sorry, I did not hear that.
So both the arms should be working in tandem, right? Like
Yes,
there is
yes,
dependency on.
definitely. Yeah.
Missing
Yeah.
camera connection. We also lost an additional 20 episodes due to resume operation mode. However, thanks to the amazing Layrova community, we were able to quickly debug and complete the final episodes. We trained on High-Zero small delay and act model. Lightning GPUs may have backed from Hackathon.
So technically, it is possible to do this. It will be tricky, but it will be amazing to try it out, especially on the ACT policy since we are training it from scratch.
Yeah, thank you for sharing that. Is it in the same link that you
It's
shared?
in the same link. Yes.
Okay.
We will probably launch
Another
a
approval for the other arm in that case.
What? I did not hear
I
that.
will need another approval for the other arm.
Okay. Yeah, they will have
Thank you,
another
sir.
hackathon this year, so many of you can actually participate. They conduct it all over the world. Okay, Pritam, thanks for the
Okay. Just
presentation.
one
Let's go
question,
ahead.
Pritam, if possible. In the training part, I saw there was a cube with different colors.
Even I saw that there was a Rubik's cube, right? Some
Yes,
yes.
yes,
Rubik's cube. So,
yes.
and someone had meant keep how it is not the ideal training.
Yeah, yeah, yeah.
So,
Yeah, I think the video that I captured, I was capturing during the first training, and then like I said, I changed the batch and everything, right? So my kiddo took the cube away, and then I had to train on her like a rubber box, object. So that may be misleading,
Okay.
but yeah, I did not capture the other training video.
All right, all right. So I've received Rajesh's PDF. I'll just share my screen, and this is the correct one, right? Rajesh, are you able to hear me?
Yes, sorry, I was talking. Yeah, I can hear you. Yeah, that is one of them. There is another PDF also I have sent.
Okay.
Can I control that desktop?
I'm not really sure how that can be done.
Um,
And I can scroll through. You
oh,
can
please. Yeah, thanks. Oh, this is just
see this. You can see both the screens.
I can see, I can see. Now, can you, I mean, there is a way to zoom also. That's okay. People can see it. Well, I'm Rajesh and I am from Bangalore. And I, like you guys, I'm a robotics and AI enthusiast. Maybe we can go to the PDF.
Yeah,
Uh,
sure.
yeah. What I did, I have summarized, like some of you, it was very easy. I just followed the instruction and the baseline to create was very simple. It was like a cookie cutter. It worked out of the box. Um, Next screen. Uh, yeah. Out of the 10 experiments I did, seven of them were successful. I could complete, it can pick and drop and come back to the reset position and all that. And two of them worked sometimes, but not all the time. But one was a utter failure. So we'll go through some of these and we can discuss. And the moral of the story is sometimes more is not always the better. I mean, I would like to set a lot of hyperparameter to make it more, perfect or something, but it doesn't work that way. There is always some threshold. You're playing with a threshold. If you go a little bit more, you're that way. If you're a little less, the other way, or something like that. And the default, whatever they have given, is pretty good. That's why my main baseline was already good enough. Yeah, can we go next? Yeah. What I did, I divided this whole thing into 5 phases. So that's how I've evaluated all the settings. I've written a small software also where maybe if time permits, Rajat can scroll there later, where I evaluate all of them and give rating, and it takes it, analyzes, and creates a report also. So these are the five, let's say, modes. One is approach from the static starting point. How does it go? Is there a jerk? Does it go smoothly? I rate it myself manually or with a paper. And then does it pick properly? And then the transport, does it move? And then placing, if you see my setup, unfortunately, because I can't share everything, I had prepared more things where I could show you exactly. I think you have seen the video, my video probably in the
Yes, yes,
Discord,
yes. I've seen
where
it.
the
Yeah.
box is pretty small, tight. I wanted it to be like that so I can really understand. I don't want it to have excuse of dropping somewhere, so I can really study accuracy. And then the placing is the issue, plus the reset. After it places, it has to come back safe and then rest. While if I take that object and keep it back, like you, Preetham, my son is grown up, but he was amazed and he was only playing with that. So I agree with you. They get fascinated. Even I was fascinated. Yeah. So that is just with the baseline. Now, if you could scroll. So what I have done, I put some, these are the things that I thought I would like to experiment with. As you all probably know, I initially I was very ambitious. I thought, wow, there'll be such a big variation. So maybe I could put this, the Cohen's D parameter just to see which one has a bit larger weight. But actually, by the end of the day, they were all very small. So we could almost assume the baseline is pretty good, but there are we will go through some of these settings that was surprising. Some were counterintuitive. So I would like to share that with the group. I started with a chunk size of 50, and then I trained my baseline for 50,000 steps. And because I have my own computers, so I have a system of 5 nodes, um, and I've created a cluster, and I could test parallelly many things. So that made me test all these 10 very comfortably, locally. Then, this temporal ensemble was pretty smooth for me. We all know it's like, my analogy for that is you are climbing down a mountain, and sorry, not that one. No, no. And temporal ensemble is you have seen the video camera how it stabilizes. There will be a small delay, but it still can. It will give you a very smooth movement, and that is I could realize that with my robot as well, arm as well. And KL weight, well, I think this controls the balance between the reconstruction accuracy and the latent space regularization that Dr. Ajat has spoken in the class, where higher value will be more smoother, but then it loses precision, and lower would be may overfit. But in my case, what I found, if I had the baseline, I had the lower the KL weight would have yielded me a better result, because you will see some of the results later. Because I guess it's a simple task also, just a pick and place. It's not more complicated, I am assuming. Then also this learning rate was very interesting. That is the one where I really like, where you're walking on a mountain, blindfolded. If you take bigger steps, you may fall off the valley somewhere by accident. But if you take a small steps, you take a long time to climb down the mountain. So there is again this, should I do it with a smaller, that e to the power of 5 or e to the power of 6? Those are the parameters. If you go e to the power of 4 or 3, you will not, you will miss, it'll be very jerky, it'll move away, move fast, knock off the object and so on. Whereas what I did, I went, by default, it is e to the power of 5. So I went to the e to the power of 6 just to try. I really liked it. And that I was always, initially, when I was thinking maybe my data was not captured properly, that is why some of these experiments are not successful. But this gave me a lot of confidence. It worked, flawlessly. So then I knew my data capture is not an issue. I only collected 10 episodes and ran 50,000 steps, for training. So next, the dropout is stay there only. Dropout is where the regularization technique that randomly turns off neurons during the training to prevent overfitting. This is very fascinating for me to, I'm so new to all this, so it's very exciting for me, the dropout. Because it doesn't allow overfitting, because it randomly powers off the neuron, so the model has to learn more a generalized path than a very overfitting path, and it can't also memorize anything. So I think that it's more fun for me with this dropout, was much more fun to test than all the other ones. Plus, also another thing I learned, I believe, I don't know how to understand this, where the neurons also, I believe, cannot codependent on each other, because randomly it switches off. So this dropout, it's something, it's very exciting, I think, for us to explore, I feel, along with the other ones, naturally. Yeah, we can go to the next one. And here is a summary where, for me, the baseline worked out generally okay, where every most of in my data collection and inference pickup was very close to 5 out of 5. It's a scale between 1 to 5. So it was almost 5 out of 5. The pickup so beautifully it picks up the object. It's very satisfying. The approach sometimes jerky, very fast it goes and shakes. This kind of not too much, but still, you're not happy with it. It's not beautiful. So and then after the pick is the transport. Then the placing is where if there is only one variable through which I can determine this whole exercise, which is the placing. If that breaks, somehow you can pick also weirdly, but the placing when it fails, the entire episode is a failure. That's how it is rated because it can't even come back. It gets stuck there in the box. It moves the box and it just thinks a lot, doesn't come out. Timeout happens. Many things happen. So for me, if at all there is one variable that will determine the success, that would be the placing. Yeah, next, please. Temporal ensemble gave me the very, very satisfying results. And then a surprise thing for me was this dropout and ResNet. I don't know whether I haven't said until now. By default, it is the vision model where they have taken, I think, ResNet 18 by default. By boosting it, maybe let us go through, maybe I will talk about it. But what I wanted to say is there are 2 experiments out of the 10 that just all the pieces were out. Five, 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 five. I mean, even better than baseline. Even baseline, I was not that satisfied. The resting position was not good. Sometimes it would get a 3 or 4. It is not because I conducted 10 times, each experiment are conducted 10 times and measured. So you will see some variation, but I kept everything same. So, but then you still see some variation. Sometimes it gets compounded also, some errors. It is interesting to see. These are the 2, but we will get back to these 2 probably later if we have time. Yeah, Rajat, yeah, thanks. Yeah, so out of the these were okay, yeah. If we were for others if you want to play with those hyperparameters, I found these were more conducive for us to play with very low risk. They will always either improve or doesn't destroy, or you will see something positive. These were the variables that were comfortable to change. And mostly I found lowering than the default, it was the direction I felt it was going. But I mean, you have to see in your environment. And also I did turn off the VAE as well. VA is supposed to make it more adaptable, but by turning off, because anyway, it's the same, there's nothing more rocket science in what it was trying to do. Surprisingly, it was less jerky because the path to take probably was much less. So I don't know, but what I found by powering off, setting it to false or something, was less jerky. And then KL weight as well. By lowering, I noted something like a human would move, where it's again a counterintuitive, but it was interesting to see. It would come with the same poise, it would drop. I liked it a lot. So I felt like a natural feel. And the learning rate, as I said earlier, the lower yielded me, better convergence with the training itself, what I had done. And overall, the chunk size, because my baseline was 50 and chunk size 100 definitely, made the whole thing look smoother. And I did combine some of them. Like, for example, the KL, lower KL with the chunk size 100 was almost near perfect. So when some of you are training, we could already, you could go there directly just to have a good feel, instead of other parts. Yeah, next, Rajat, please. Yeah, here I feel if I had a better set of eyes, I will perform better. So if I had better visual, model, I would imagine it will yield a better, but it will require 22 gig, I forgot, 24, something gig RAM, VRAM. So you need a lot more when you increase the ResNet 50. But surprisingly, it was not the case because I think the base when I don't know why, but it especially it has an issue at the dropping. When it wants to place it, it gets some reflection. I don't know what it was struggling. So for me, if it cannot do the placement properly, the whole exercise is like a zero or something. That's the whole objective. Because what happens, it'll bring the object directly to the rest area without dropping also. So all this mess will happen. So this was a counterintuitive for me. I don't know why, but this is what I saw. Making it I think it became too sensitive. Next, Rajat. Thanks. Huh. What another thing? I thought we only have 10 episodes, only five. I mean, very basic. Why not we reduce the model dimension itself from 512 to 256? You can reduce. It was a disaster. It doesn't even know how to go. It arrives and knocks off the object somewhere, and I had to keep it. It doesn't know how to pick. It was very weak. It was really totally handicapped. It was total waste. This one, not even one successful episode we could catch. So it was total disaster. So I think they already have kept a good optimum thing. So anything we try to reduce this value will be worse. But the positive is it'll train very fast. But that's no use anyway. Yeah. Next. Yeah. So yeah, overall, what I found is anything that failed was always failing in the placing in my context because my placing is very tight. It's not a big box. So this is my takeaway. Yeah, next. Yeah. As I said earlier, better object recognition with ResNet 50. I thought I will have a better result. Very proud. It took so long to train with a lot of memory, but useless. And reducing the model size was total. At least with the ResNet 50, the surprisingly we did have some episode go very well, but not all of them. 10 out. It was not a 10 out of 10. So that maybe 8 out of 10 or 7 out of 10 or something. Was successful. The C1 of the light model, reduced model to whatever I did, total catastrophe. It was waste. But temporal ensemble was very smooth. It was nice to see. Lower learning rate also yielded a very good, almost actually better than baseline, but I think in the report it's very close to baseline. Yeah. Thanks, Nathan. Yeah, at the end of the day, most of the gain what I saw overall, even though as a human I find that I prefer this, I prefer that, and so on. But technically, our baseline was able to do everything. Yeah, within some jerks, and it's not smooth. And so it's only, if you accept the task completion as a goal, baseline was good enough. That's the summary. Yeah, next. Rajat. So a takeaway is, look, the model dimension should never be decreased below 512. And I think for the rest of us who are still to do experiment, you could safely tune on off VAE or chunk size. More is always better. And LR and KL weight you can play with. And then the dropout, especially vision backbone. I wouldn't consider it as a total failure, but still, it's a bit risky to try and drop out again. It's an area I'm really fascinated, even though it is risky because you're going to turn off neuron randomly inside. It does by itself, and then it forces the model to learn. So it was something that I want to really play there more. Yeah, thanks. So bottom line, I think the baseline what they have done, it already respects the threshold. So no matter what we are trying to do, that's why we can't find a big gain. It's already pretty close. What we got with the baseline, what Rajat shared with us on that GitHub and that whole thing. If you just copy paste more or less, that's already there. And then. Yeah, when it fails to place, it's a complete failure for me. And surprising was I combined two things together: the ResNet plus, which is risky, plus the more bigger vision one, and the dropout. I tell you, that was the best ever, 100% smooth, everything. It's so, again, it came as a big surprise. Better vision with, I think it forced to not to have any overfitting or memorization or co-adaptation or something. I think that is why this yielded fantastic. That is my goat. You know what I wrote at the very beginning, the best performance. This is one of them, which came in as a surprise to me. By alone, they were not so great, but together they were the best. Yeah. Yeah. I mean, I've been repeating that baseline is robust enough, so nothing much, and that's it, Rajat. There's nothing much here. Yeah. Sorry.
Yeah, overall, Rajesh, I think whatever you have said in these slides is very important for all of us in the class. It sheds light on so many interesting things, in fact, and a lot of things you have explained from first principles. I really enjoyed your PPT. Uh,
No, thanks. If you go to the other slide, 2 seconds only, at
yeah,
the
yeah, yeah, sure.
bottom, if you scroll, is there a way? Okay. I wrote a software. Just
Okay.
scroll up a tiny bit, which has, one more up, which has 21,000 lines in shell
Oh,
script.
amazing. Okay.
And it has 90 menu. Really, it's like a tool for me when I sit.
Oh,
It is an extended arm through which I can do so many things.
yeah, yeah, yeah. This is very cool.
And here you see I have a queue management. It knows
Mm.
which experiment, which hyperparameter should be given, which node in the is free, because there are 5 nodes. It will allocate depending on whichever is free. And then, sorry, you went a little bit fast.
Yeah, yeah, I'm just excited to see what will be. So,
Okay. And then also nightly, it will update. I mean, if you scroll all the way up, I mean, down, whatever, sorry,
yeah.
the last page. The last page. Yeah. No, this is architecture, but it's boring. Yeah, stay here. Maybe if you can scroll somewhere. I mean, if I zoom out, or I don't know, somehow. A little bit. Yeah. This is There are 9. This is how I was playing with this, where see, they have given us a simple
Mm-hmm.
one run. You can run once type of a thing. But I wanted a session based, so that I want to run all these experiments in the same same drive, no? So the same folder. So I've created a concept of sessions, and the same data set, training data set will be used by multiple sessions. Plus, in my context, I also have nodes. And the very exciting thing for me was, let's say the fastest node, if it becomes free, without losing the progress, it will be able to copy the entire training from the slow node to the fastest and continuous. So that way I can
Mm-hmm.
just fire it and go and sleep, whatever, out and come back. Everything will be done. Report will be generated. It was really, really, I enjoyed, by the way, thanks to you. You forced us to do something. I
Mm-hmm.
enjoyed creating the tool, plus, of course, the experiments. That's why I was able to do the experiments, because of the tool.
Yeah. This is very, very interesting, Rajesh. So. First of all, yeah, regarding this, all these insights which you have shared, I think this is very knowledgeable for all of us to learn, because many of us will encounter a lot of these issues, and uh, we have conducted a whole range of experiments here, which is allowing us to observe a lot of things. And I enjoyed this vision part also, where a Resnet 50, that was counterintuitive to me also. And one thing I was curious to understand this about this combination you have not reported at the top here, right? Where you explain about these
Yeah,
different.
here,
Yeah.
the 5.0,
Here you have not reported that one.
No, here, yeah, because it was not the success, it's not the safe one. It's not the
Okay.
safe value,
Okay.
risky value.
This is the risky bet.
Yeah,
Mhm.
if you go a little one slide up, you will see, up means the, yeah, here, you see the right one.
Okay, okay, okay. This is the one
That's,
you're talking about.
yeah,
Okay.
it was very robust. Even though it was a risky, both of them you feel like risky, but I think drop out, there is some secret there. You're really forcing the
Okay.
neuron to learn.
Mhm.
There is something there
Uh-huh.
because I don't understand much. I don't
So
know.
did you just try the dropout just with the baseline without ResNet 50, but with the original ResNet?
Yes. I have. I have. That's one
Okay.
of the experiments that was done. Yeah.
Okay, fine. Okay, okay.
All of them I've done alone with the basenet, all the parameters you're saying. And then I combine versions. I think I did maybe three or something, or maybe
Mm-hmm.
two or something.
Okay.
Yeah, that's all. So otherwise, everything one
Um,
at a time I have done with the baseline.
yeah, so this is interesting combination of dropout and resonant leads to this. I mean, you have got a great accuracy here, scoring 5 out of 5 on all phases. First of all, division of this into phases is also very nice. I like this. It's last time we were discussing about evaluation, so this is the right way. I think we should have these kind of metrics to evaluate. It should not just be based on whether it's putting it in the pan or not, but all these factors are very crucial. Yeah, among all of this, dropout interests me a lot as well. And then maybe learning rate, not that much. Temporal ensemble is very interesting. And then the vision part, which you mentioned, that is also, all of these are really interesting to know. Yeah, I mean, I want to think about this more deeply. Maybe after today's call, I'll also go through this in more detail, and I might have some questions which I might ask you based
Sure,
on
sure,
this.
sure, sure, sure. We can even do a session,
Yeah, yeah.
run a
And
test, everything.
I think all of us will benefit if you explain to us how to use this, because maybe can you make a video or something where
Yeah, I
this.
can do a demo also. I mean, I need to find a way how I can share my screen. Oh, from a Mac maybe. No, but then I
I
don't have
mean,
this.
if anyone sitting in their home with their own laptop wants to use this tool you have built, then
Hmm.
how can they use this tool?
Okay,
That is
I understand. Okay. Hmm. Let me.
because
I mean, I have to think because I just wrote
yeah,
blindly
it
to
is.
arrive at today's presentation.
I think it's very valuable. It's really valuable for all of us to, first of all, tool is the secondary part. What is more valuable, I think, is this, the results, which all of us can learn from. And then having the tool with people,
Was the reason I could finish, I felt.
yeah, that's very, it's like it has helped you to carry out all these experiments in a short
Correct.
amount of time. Otherwise, it is
Correct.
impossible.
Correct. Parallelly, I could do and the two local node.
And how much time you have spent on this whole project overall?
Oh, I'm fascinated, passionate. I didn't count, doctor. Uh,
Okay, okay, all right.
but I mean, any time I mean, late nights and I get
Yeah,
excited when I see this. So
yeah. This is very cool. I'm sure all of us want to learn how you have made this. I have not seen this interface also before. I don't know what these progress
this,
bars and all from where they are coming.
yeah.
And
Yeah, I wish I could. But and I had another issue. Can we do in Google Meet or something else one day? Because
definitely, yes,
that
yes.
computer from where I want to demonstrate, it is the Blackwell, whatever that architecture is ARM core, where these guys don't support. Zoom doesn't support. Nobody supports. This morning I was panicking because I had prepared everything to do from that computer.
Yeah,
where the robot, everything is connected. Maybe we could try Google Meet as a separate session. I will be very
definitely. This
happy
is, yeah,
to demonstrate. We can create live experiment, publish. You will see how it
and
all picks up by itself and runs.
also
And
I think all of your results can be converted to a technical report or a paper. I think not just our class, but everyone can learn from this. I have not seen this anywhere, this kind of studies. I mean, varying these parameters to that level and understanding the influence of each. I think the broader robotics community can
by the way,
benefit.
I have also joined your reinforcement learning bootcamp.
Right, right, right. Okay.
Um, if this helps there, I don't know.
Yeah, this is something which, yeah, I mean, this format is a PPT right now, but it will be great if this is converted to a technical report or a paper.
Hmm. If you guide, I can do it.
Yeah, yeah, definitely. We can maybe get on a call and discuss about this.
Sure, sure. Thanks.
Yeah, yeah. Thanks, Rajesh, for this PPT. Let's go ahead. Yeah, I think everyone has liked the PPT as we can see on the chat, and the explanation was also from first principle. So that was good. Like you're thinking of machine learning as a separate field and application of ML to robotics as a separate field. So that is very interesting. Both are not one and the same. Okay, let's go ahead. I think Vishnu and yeah,
Yeah,
Vishnu. Yes, yes.
I can go ahead.
Yeah, yeah, please.
Can you see my screen? It should be my browser. Can you see?
Yes, we
Can
can.
you hear me at all? Okay, all right.
Yeah.
Hi, I'm Vishnu. My background, I also live in US. I'm in Boston. It's like 1:10 for me already. So I had my master's in robotics, and I've been working in robotics industry for about 6 years. I worked on autonomous vehicles in San Francisco area, and then I moved to Boston area again. Right now, it's warehouse mobile robotics. So my background is in motion planning and controls. Not much on machine learning or perception. I even though I have a background there, but it's not like I don't have experience there. I want to get more experience hands-on. That's why I joined here. Uh, Getting into my setup and experiments. This is the hardware setup I have. Uh, this is how I set up my experiments. Like I at the very beginning, I wanted to have like 5 different tasks that I designed. One is this pick and place, and this I also wanted to see how this multimodal uh, problems are there. In robotics, we actually see that multimodal problems appearing everywhere. So I wanted to have a simple task where you just need to cross the line. You can go from left or right. So there's like two modalities. So I wanted to see that, and also I tried all of this with uh, Teleop. We can do all these 5 tasks. Like there is nothing that we can not do with this setup. But I only finished task one, pick and place, and I had this configuration when I gathered the data. I did it from 5 different locations to 3 different target locations. That's how I collected like 110 episodes here. I have that data set. This is about data set collection and then how I set up my environment. And I had wrappers around what Layrobot already gives us, the Layrobot teleop, Layrobot record, and Layrobot train. So instead of like specifying each and every camera parameter and also for ports for serial communication and all, it's going to be there in the script itself. It's just a uh, it's just for convenience. That's it. There's nothing much done here. Uh, and then I also wanted to start from the beginning. If you think about MNIST data set or maybe any image net, right? So we have image and then we have this label. We know the entire pipeline, but I also wanted to see how it is working here. At every step, we have 3 images. We also have the state of the bot, like the state of the each joint. And what exactly are we comparing at the end once we go through the model? And that's what I wanted to have a visibility into. So I did some experiment. That's what I wanted to show here. Uh, and I would say I sort of like understood there are a few more things that I wanted to understand from the first principles, like this multimodality thing. I did some experiments like with 1D distributions. I think I got something there. Uh, yeah, once I have this data set up, I have this training pipelines understood. Uh, I just went ahead and used when I started doing it, I did it from my computer. I had 4080 RTX, which has 16 GB RAM. Uh, it should be fast enough, but it was not. It was only doing like 2.5 iterations per second. And then I went through the paper ones. They mentioned that they were using 224 cross 224 resolution for ResNets. When I did the change, it went up to 11 iterations per second. It was 4x improvement. So yeah, that was there when I wrote this train act script. I made a mistake that I was not logging all the validation stuff that I wanted to do. It was only the L1 loss and L2 loss and total loss. Uh, and these are the parameters that I had. This is from weights and biases. So these three were the quantities that I logged. So I could see the weight, loss going down, but I was not sure if it was underfitting or overfitting. So I just took it as like even the loss here. If you see this, this is not that didn't go below zero. I saw a lot of people have their loss going below zero. Uh, I can attribute that to this complex data set that I have. It's like 110 episodes uh, with uh, uh, with different configurations. I was also like inspecting the data uh, once I trained the policy and I evaluated it and I was comparing what the live data is looking like and then what it was in the data set. It is slightly different from lighting conditions. Also, my overhead camera slightly moved. So yeah, it was not good. But at the end, I could do some pick and place stuff. It was successful most of the times. And then here we can see that effect here. Like it was trying to pick from here. It was going to place there. Like I said, the overhead camera mode, I could clearly see that. So there is no spatial intelligence there. So uh, yeah, I would say overfitted to the data just by looking at the performance here. Uh, but I don't have any other quantifications to, or maybe plots to justify that claim. But it looks like overfitted here. Yeah, these are my results. But I also wanted to see. I also wanted to have more understanding about. I think I just discussed this. So this is what happened. The top view camera slightly changed, and also all the data that I collected that was in the daylight. When I did this evaluation, it was during the night. I had this white light, different shadows. So yeah, I think that affects. Maybe we can do better study there how it's going to affect. Uh, and then I wanted to understand this from first principles. I wrote a Medium post like if I can actually show that. So I created this. So these are the 5 episodes. Like I want to go from this point to this point. I can go in 5 different ways. It's like very small data set, and then we can go through each and every point. I spent a lot of time just to understand each and every component there in this architecture. Uh, if you are interested, I can share this thing here and also have the collab notebook if you want to try that out. Uh, and then, yeah, again, I wanted to have a good understanding about all this validation and then how this training is done. How do we decide when that is overfitted, when that is underfitting, when that is right enough? I use this Pushti data set. There is, I think a couple of people did this ACT policy. Uh, they trained ACT policy on Pushti data set, but I couldn't really run it, and there was no I couldn't successfully run it. Actually, I could run it, but the success rate was almost all the time it was 0. So I wanted to go ahead and train it myself. So I could get the success rate above 50% with this Pushti data set. It's again the same ACT policy. I did this parameter sweep. We can actually see that here. If we have it here, I can show. So there are like 4 different sweeps. If we go to sweeps. So we can sweep on different parameters, like learning rate. That can be one parameter that we can sweep on, and then and I also swept on chink size. I'm trying to find exactly the thing that I was showing here. So if you look at here, there are all these the hyperparameters. What I was trying to maximize was the success rate. So it goes through all different combinations, and we can pick whatever the model that gives us best success rate. So this was the one that was giving me maybe over 50% success rate. So now that I have this pipeline, I can go ahead and test with my data set from this robot arm. But the only thing is that I need to come up with something like this eval success rate, or maybe like some other metrics that I've been working on. Once I come up with this metrics and come up with a way to compute those metrics, maybe I can push them to weights and biases and do all those parameters to even just for this 5 episodes. It took like the whole night on my computer. So now I'm confident in my pipelines. I can go ahead and then purchase some compute time online. So yeah, these were the experiments that I've been doing. And then yeah, the next step, my immediate next step is to like fix my environment. My camera is not fixed, so I need to do that, and also standardize lighting somehow, and do more data collection. I only did this task one, pick and place. I think I need to redo that because my setup is disturbed right now. And also do this training analysis. So I wanted to do the training loss and also validation loss, set aside some data for validation, and then compare those curves to see overfitting or underfitting. That's very important to understand, which we don't really get just by looking at training loss. That's my immediate plans. While I was having all the discussions and looking at the conversations in our Discord channel, I came up with this idea. I have this question, like, what's the optimal chink size? Uh, can we come up with a systematic analysis? Maybe that can be turned into a research report or something. From Pushti data set, what I understood was that if we do chink size 50, that gave me 50% success rate. When I did 100, it didn't. But with S0-101, we need 100 chink size. I have an hypothesis from the hypothesis is from there. Like if you want fine grained tasks, we need to have a smaller chink size that gives you like more reactivity. And if you want to have the gross tasks, like move this object like a meter away, it's okay. Like 1 millimeter, no, it's not. Then you need to have like very small chink size. That's my hypothesis. But I want to test it by doing more experiments. And also the scaling loss. I think it was Harsha. Someone was saying like when I have 20 demos, the performance is good. When I have like 100 episodes, the performance is getting worse. I was reading something about it. It is called representation collapse. There is this concept in literature that I just found out yesterday. So I wanted to do more studies on that. And this control barrier function, it's in my domain. So usually when we talk about this control barrier function, it is in the context of the safety of the robot. So to come up with this function, you need to have the model of your robot. But in this case, we have this just robot arm. We can write a model, kinematic model, even dynamic model. Then we can come up with this control barrier function. But right now, we are not working with any models here. So how can we come up with these functions and apply on top of what our model infos, make it safe? it's like just filter out all unsafe actions, only make it uh, past safe actions. And I also want to include more models, like by getting some spatial intelligence and add more data. The reason why I spoke about the spatial intelligence is that I got this uh, uh, real sense camera that gives you this depth information. Right now, when I train, I'm using RGB information. I can do this depth information also. Yesterday, there was a paper. There was a software released from some Chinese research firm. It's called Link Depth or something. It's going to give me very very good depth information. Once I give this RGB and raw depth information, probably I'll try that again next time. So these are my ideas, but I couldn't really spend much time after the weekend. The whole weekend I spent, but after that I couldn't really spend much there. I'll see if I can go
Yeah.
ahead and then do something from them.
Yeah, thanks a lot, Vishnu. It was a very, very interesting presentation. I have a lot of questions. So, first of all, it's good that you are focusing on first principles, like the Medium article. Can you share with all of us on Discord?
Sure, yeah.
And yeah, that was good. Also, initially you started out with the intention of, yeah, I think all of us have liked the BPT with the intention of using the ACT policy on several different tasks, right?
Yeah.
So I have a fundamental question in the push T slides. Okay.
Mhm.
Is it a simulation environment which you are using to implement the ACT policy?
Yes. It is a simulation environment. It is a Zim environment. So
What is the name of? Is it ISAC sim?
no. It is simple. Uh, Actually, it's a box 2D, I guess, for dynamics for collision checking. That's what they use. But that is from Layrobot, I guess.
Okay, so this you used from the Laravel library itself, is it? This simulation
Yeah,
environment.
yeah, 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 yeah. But I didn't really use simulation to collect the data. They already have the data set.
Yeah, yeah. Can you share instructions on that, Vishnu, on Discord?
Sure, yeah,
All of us
yeah,
will really benefit from that.
yeah.
Like how to use. So what I'm trying to understand is the data set which is recorded is on the actual data set, right? How is it transferred to the simulation exactly?
No, it's a simulation. It's the same simulation everywhere.
Okay, so the data set is also collected
If you
within.
if you if you if you click on the link that I just sent,
Yeah.
uh, if you see the video preview here,
Okay, okay, got it,
so
got it.
you can actually use your keyboard and then do
Yeah,
that
yeah, yeah.
push
So it's
the
like a
thing. So
simulated
it's going to
data.
be this. Yeah, yeah.
Understood. Okay, okay,
It's
got it.
like it's like it's not ISAC sim fidelity. It's just normal thing. But it is still giving you one image and also all these
Yeah.
actions, right? So it's
This
good.
this is a very
Actually,
interesting.
there are two ways. Only diffusion policy is trained on this environment, and also there is another version of diffusion policy. It's called diffusion key points, where
Mm.
you only get key points of the T. It's not the whole image.
Okay, okay.
So it's very interesting.
Yeah. This is
Then
very
I
interesting.
then I wanted to do act on that. It
Yeah,
did work. It was I could get to that 50%, but I wanted to do more. I'm working on this evaluation library in general for robotics. Like that, it cannot only be success rate. When you look at, I showed you this parameter sweep, right? I was only trying to optimize the success rate, but that can
yeah,
be smoothness of the trajectory, that can be curvature change, that can be path length.
yeah.
So there can be many
I think
metrics. Yeah.
this path is very interesting to explore. Like on simulated data, you can try out a lot of policies
Yeah.
and variations in policies.
Yeah. It is faster once we are good. Once we are confident in our pipelines, we
Right.
can work on collecting
And
more data and then evaluate on the hardware itself.
in the initial part of your presentation, you mentioned is the script you have written for ACT like a custom script or you have taken it?
No. It's a instead of like typing Python robot train hyphen output directory out hyphen policy type. I just put everything inside one script. I know my ports. I know what policy I wanted. I know all the
Okay.
parameters that I wanted to use. So
And
I can share those scripts also if you.
you recorded 100 episodes, you said, right? For the
Yeah, it's about 2.5, 3 hours.
Okay, that's like a lot. It's
Yeah,
yeah, okay, fine.
that
Mm-hmm.
I just wanted to have like diverse set of data, but
Yeah.
that might be hurting. I've been searching for uh, some reasons. I've been searching for explanation. Then I
Yeah.
came across this concept called representation collapse. I didn't intuitively understand that
Okay.
it, but uh, that might explain it.
Yeah. You've done a lot of new things like new episodes, then addition of depth, trying out simulation, a lot of things.
I have depth information, but I didn't add it to
Yeah,
the
yeah.
training.
You haven't
But
used it, but at least
yeah,
that
yeah.
first step of capturing the depth that you have completed.
No, it was only for a few episodes, but that 110 episodes I didn't capture it because I ran into some issues. It was the camera was disconnecting. Maybe it was because of the bandwidth, the port that I chose for USB. Maybe I need to
Yeah,
upgrade
real
it.
sense requires both power in the
Yeah,
USB-C plus also the bandwidth.
yeah. I
Okay.
think I was using USB 2.0.
Oh no.
So, so yeah, it's not a good idea. Maybe I
No.
need to upgrade my hardware here. And then I'll get this depth information. My initial idea was to just get that
Also,
RGB and then depth information encoded into the float numbers.
uh,
Uh,
that that
Maybe
that
I'll have to see. Yeah.
that would be interesting. Also, I noticed from your initial discussion presentation slide that you have experience in motion planning, right? So,
Yeah.
if you neglect this modern robot learning methods and just focus on classical robotics, it will be
Yeah.
interesting to compare how the act policy performs with respect to a traditional where you just like let's say how a gripper should move, how the end
Yeah.
effector should move. So then, can
Yeah.
you track the movement of all the joints using inverse kinematics and but then whether it's good enough to like
For that we need some sort of localization. Maybe with this two camera setup, maybe I can do that. You need to be localized. You need to be able to localize the end effector,
yeah,
and then when you generate your trajectories, like in that 3D space, right? So
that is interesting. Okay.
yeah. So when you go to industry, like wherever you have your robots deployed, it's like you
Mm.
have origin at your robot base, and the whole space is mapped. So you know where the end effector is moving,
Correct. I
depending
mean,
on where
what
the end
I
effector
did,
is.
Vishnu, in my case, after every test, let's say I do 10 episode, after every episode
Mm-hmm.
in my pipeline, I did what exactly you just said. The neutral position of the arm,
Mm-hmm.
I recorded all the six, values, and then my Python script will do this inverse kinematics where, because it recorded all these positions manually first as a
Okay.
reference, that becomes a waypoint to which it arrives safely, and then it knows
Yeah.
how to fold to the rest position already there and so on. So
Yeah.
I always started in exactly the same starting point because as soon as an experiment ends, this guy kicks in, brings that arm to the neutral position and resets it back to the zero.
Nice.
Mm.
Yeah. Somehow, the bot needs to have the spatial intelligence. I wouldn't say intelligence, at least uh, be able
Yeah.
to localize the end effector. Uh, we either have this very expensive localization systems.
Yes.
On our mobile robots, we have this LiDAR and then be able to do the SLAM.
Okay. Okay.
Yeah, that's not. I mean, yeah, we can still compare. When we compare, it's definitely going to beat this VLAs or anything
Yeah.
that's happening right now. But those are like very specialized, right? So that's why they can do. They can be successful all the times.
Yeah.
They
Yeah.
are
Yeah.
making cars now. So we are trying to generalize. So we are
Yeah.
trying
Yeah.
to fold the globe. So so yeah, it's definitely it, it it is serving different purpose. That's what I
Right.
would say.
Understood. Yeah, that is clear. Yeah.
Vishnu, you're good in Slam?
Uh, I can do Slam.
Oh, then I'll talk to you. I have a robot.
Alright.
Okay, thanks, Vishnu. Overall, very good work. And I think you're just in the initial or slightly advanced stages, but you have a lot of ideas in your mind, which I can see. Like once you get time, you can.
Yeah. I need to find some time. I also I attended Raj's SciML thing. I worked on some idea, but I was not able to put everything together to go for a paper or something. So maybe
It's
I
good.
can I can I can explore something
Yeah,
to
your
combine that SciML with this.
yeah. I mean, your thought process is in a new dimension for our class. So I think it will benefit all of us in the directions you are thinking.
Right. Yeah, I can share like some papers or any articles that I find. I'm trying to come up like even for L1 loss. We're talking about L1 loss. Like why do we need L1 loss? Then I was reading about this multimodality in robotics. We can start with L2 loss. It's going to optimize for mean. When you do L1 loss, it's going to optimize for median. It's like very simple proof, but it's like it
Uh,
clicked. I was like wow. From
yeah,
there and then diffusion falls. So it was good.
yeah. And towards the end, you mentioned one something that was released last week, right? With respect to
Yeah, I can find it right now. Link depth,
even I read
link
that.
bot.
Uh,
I tried it. It's like I tried on my computer with this RealSense. It was pretty smooth. I was so excited. I was like, just that it was taking like 2 seconds to create that. It's not going to work on the bot, but
yeah. This
uh,
limbot
yeah,
depth.
yeah. It has real. They have all this VLA stuff also implemented.
What does it do
I want to
exactly? It
explore.
was not possible before. What does it do?
The link bot depth.
Yeah, the limbot depth. Yes.
If you maybe I can show with the picture again. You saw the depth information, also
They
the
claim to
RGB
be
information.
spatial. Yeah.
Uh,
Yeah, I'm sharing my screen and looking at their GitHub repo right now.
you see these two images here?
Are you sharing something or
Yeah. I'm sharing.
me stop? Okay.
So this
Yeah.
image, this depth image, and then this one here.
Yes.
So this is the RGB, and this is the corresponding depth information, but it's not. You cannot really make it clear. Like once you switch to 3D, you can actually see all the points. Point
Mm,
cloud actually. So
Ah.
the point cloud will be smoothened out, and you'll have like very smooth depth information. It's like correct depth information. So they trained with the Z camera and also RealSense camera. They use some other camera. I think they have it here.
What is the
Uh,
edge device? Did they mention?
I think they mentioned, but I didn't read all of it.
Okay.
So yeah, this is so noisy, and then you're going to get like pretty good uh, information and semantics. You can do segmentation on that.
You implemented this
So
Vishnu as well, this
what's
limbot.
that? I didn't get it. Sorry.
No. I was asking, did you implement this and check if it works?
No, not implement. Just follow their instructions here, and you
Oh,
can do this example
No,
PRI.
but
So
first you have to
just
change your
install,
USB.
install. Yeah,
First you have to change your
yeah,
USB-C, otherwise it will not work.
yeah. Sure. They have these examples also, and then you can just try out those examples. They have depth information stored in NumPy arrays, and then they have this PNG file. They'll generate this point cloud. You can use Meshcat or something to visualize it. It's pretty cool. Yeah,
so
they'll generate all these files. This is
You
pretty
can use
simple.
this for SLAM also, no, Vishnu?
Yeah, we can use this. Like, yeah, we need. Uh, it depends on where we are doing SLAM. So you'll have to write the
No, once
problem.
you have the point
Uh,
cloud.
yeah. It's like writing the problem is like uh, most of once we write the problem, there are so many ways to solve it. Solvers themselves are there, so it's mostly it's about writing the problem.
Okay, thanks, Vishnu. Good presentation. Just share these links on Discord also, so that all of us can.
Yeah, Rajat, maybe at the end I can send you a message. Like I was reading all this, I just wanted to put everything together.
Yeah, sure.
Inference policies, maybe something like a review paper or something. But yeah, I can.
Yeah. Sure. Yeah, I
I have notes. I have notes. I can share it with you.
I was about to suggest that with the group also, with Rajesh also. I briefly suggested, if since we are doing things which are like control tests and trying out new things, we should convert our findings into a technical paper. You can also collaborate with each other and work together. We can submit to some good venues also.
Yeah. Thanks.
Okay, thanks, Vishnu. Let's go ahead. I think Abhishek, you are sharing your screen, right?
Yes, sir. I can start.
Yeah, go ahead. Yes.
So let me know if my screen is visible.
Yes.
Okay. Hello, everyone. My name is Abhishek Jana. I'm a co-founder and R&D lead at Robotic Solutions Private Limited. So from education perspective, I have done my master's from BITS Pilani in AI/ML. And I was interested in this domain of robotics, but I was actually looking for some options from where I can get started or apply my knowledge or learnings that I have done during my MTech on transformers also. So I found this course from YouTube, and it was quite insightful for me to get started. So I think last week only my shipment has arrived, where I got the S0-101 kit. So this is the setup that I have. It's actually in my office I have configured. So here in my setup, I have the arms. I have three cameras, one on the top, one is already in the gripper, and other on the head. We have one cam. And I have trained this model. This is my Mac Studio, which has 512 GB of unified memory. It runs on M3 Ultra. So yeah, this is where I connected all. So actually, this studio has all the ports from the on the back side. It has four USB-C ports where I connected all the cables that are given by Wow Robo for the arms, and for cameras also I could connect without using any hub. So for me, that is working perfectly. Now, so this is how the camera views looks like. So this is the top view, is the arm, and then this is the field view camera. So here the for data collection, I have tried with two type of data collection. First, I collected 20 episodes of like pick an object. So there was an electrical socket, as you can see here in this image, and this is the bowl that I had. So though the bowl is like it's a glass bowl is quite transparent from the view, but the agent, sorry, the robot did well actually. So I did two data collection. One is for 20 episode for pick object and place in the pool. And yesterday, actually, I was showing a demo internally in our office also to the team. So where I trained another data set where if you show palm or maybe your hand in front of the camera. So in the bowl, I placed say chocolates. So if you show the palm, so the robotic arm will go there and pick a chocolate and give it in the hand. So that one also I tried and uploaded this data set here in Hugging Face also.
You have a video?
That one actually during inference, that one didn't work well. So I have the pick-in object, that video I have. I forgot to take the video of the other dataset that I have. Though if it is visible from the database, then I can show actually. Uh, so during
We should be able to see data set from Hugging Face itself, right? They have
yes,
these
yes,
viewing
yes,
tools.
yes.
Yeah, we would be interesting to see it. Like we would be interested to see it, Abhishek, your data set. Maybe initially you
Yeah,
can
sure.
go through the PPT first, and then
Yes.
you can take a look at.
So so
Like,
during my training, I tried with different batch sizes, but increasing batch size actually takes a lot of time to train the model. So this first I initially when I did training in Mac Studio, it took around 2.5 or to 3 hours to train 20 episodes, where I did train for 50,000 steps. And for device, as I mentioned here, MPS, and the chunk size was 50. Then I have another GPU that is 5070 Ti, which is 16 GB of memory. There, the same training is taking around 2 hours. I think if others could able to train in less time, then you can let me know like what optimization I can do to train in less time, because waiting for 2 and 3 hours is like quite difficult to see whether data set is working, or maybe if some hyperparameter tuning is needed, then what could be the good option to do that. So, and for inference also, I did. Is it coming? Is it coming the video to you?
no, no, it's not coming.
Just a minute. Is it coming now?
Yeah, yeah. And maybe make it full screen. Sorry.
Hmm, just a minute. So actually, I did this training in last 48 hours. So I didn't got a lot of time to tune all the hyperparameters that are available there. So there are a lot of imperfect attempts. Like this one, I have few downloaded here, uh, where the model fails to grab sometime here. So for me, the placing was actually perfect, but for to grab, it takes like a lot of effort, or sometimes it like misses, hit and miss situation is there. So I have this kind of recordings where the model is failing to pick the object.
Is this the same location where you have done the training in, or you're trying?
That is something I did tried with all location. I picked up two location for the bowl, and the object I placed all over the place during training in my data set.
Maybe you
So,
can narrow down your space. I think it's a big, like it's a big grid. Your grid which you're
hmm,
showing.
hmm.
And, you might need a lot of episodes to cover the entire grid.
Okay, okay.
Within 10 episodes, I'm not sure it'll generalize well all over.
No, this one is with 20 episodes.
Okay, okay.
You could try at each location, maybe 10 repetition could be.
Yeah. I think you definitely need more episodes, Abhishek, because or else you constrain your object space to maybe a square which you mark on
Hmm.
the grid.
So these are the current problems that are there in my setup at the moment. During inference, what is happening after the first episode? The script freezes, means it doesn't proceed to the second step. It says resetting environment, then nothing happens. So I don't know. I mentioned this problem in Discord yesterday, but I haven't seen any. Like someone has suggested few solutions, but those are not working for me. So every time I have to do a testing, I have to restart the script once again, change the valid dataset number, and then proceed. Um,
I I think even others are doing the same thing, right? If I'm not wrong.
No, Rajat, in my case, it's like autoplay. You have a set, you have two parameters. One is the timeout, another one is the
mhm,
episode, number of episode, which are given like 99,000, whatever, huge number, so that it's like a forever it
mhm,
will be playing. So you
Mhm.
you are afterwards you are only taking from the bowl and keeping in the place. It will arm will come, put drop, and this it will be fun to just this game.
Okay.
So I kept episode number is 5, but still like after first episode it doesn't move anywhere. It stays there only.
What
Not
about the
sure.
timeout thing? It's set to like
Time
20 seconds or something. Maybe you could in 60 seconds or something.
60 second. Yeah, it is 60
That
seconds.
can be the issue too, no? So you could increase that.
Mhm.
Like I had
Mhm.
made 10 minutes.
Yeah, yeah, that makes sense.
Okay. 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 So let me check. I will try out once again, and I will keep on updating on Discord. What are the observations that I have?
The second project which
So
you taken is very interesting actually. Uh,
yeah. So the data set is here. I don't know if you can. Is there any way to see the data set from here? This one? Yeah. Oh no, this one. Palm reward data set.
okay, okay.
So is there any way to check the videos from here?
I'm not sure. Here the videos are not saved. Mm,
Oh
no.
yeah, yeah, I think yeah, it's in yeah.
Okay.
The MP4 files are there. Downloads. So during demo, what I thought is like I trained the model and let me know if it is visible.
Are
So I
you
thought, yeah. So yesterday when I was giving presentation at my office, so I thought I will distribute chocolates to everyone. This robot during inference, it didn't work out that well. So I
okay?
had to manually do it.
Can you show the video? We not. Yeah, 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 okay.
Yeah, this one. This one.
Nice. Good idea. Okay, it's not going and okay. This is the training set, right?
This is the training set. Yeah. So this is the idea was which I was trying.
Maybe the hand should be there till the reset comes. Hand should not be removed, I
Hmm.
think, till the reset. As a human, we take away, but I think for the robot, hand should be there till the reset. Try that. and then the person can take away the hand in the reset mode.
Also, I think there should be some episodes where if the hand is not there, the robot should not do anything.
Correct, correct.
Yeah, so that one I tried, and I would tried another thing is like I emptied the bowl, then the robot went there, seen like no chocolates present in the bowl, then it went back to its position. So that one also I tried.
I really like this idea. It's interesting. Uh, hmm. How many episodes did you record for this?
This one I recorded 12 episodes.
Okay. Maybe you can keep the hand stationary for the entire episode then. It'll be too
See, the
complex.
person already took once straight away back, second time to the right. I don't know whether all these will confuse because we are worried about black
Yeah,
wire and all that and such a big movement. I don't know. I'm not too sure. I mean, I will also try. I really
yeah.
like this, but I'm inspired by this by you.
Yeah,
Thank
yeah,
you.
it is a very,
It's
very,
really fun. You made it something human.
Yeah,
very cool
yeah.
idea. This is one episode, is it, which you're showing?
No, I think they have three files. I think they have merged all these one single videos into
Makes
three
sense.
files. So there are three files, 126. And another problem that I face, I could not connect the weights and biases for some reason. I'm generating API key there, but the terminal expecting the API key to be of 40 characters, but the
That
API key
happened with
that
me
I'm
also. The issue is you have to upgrade your wand V. Then
okay.
that issue gets solved. That happened with me also. Just upgrade
Oh, okay.
just upgrade your version, then it will be solved.
Yeah. All right. And I think in your repo also you can also mention the support for this Blackwell series of GPU, these 5070 series, because
Right.
the repo doesn't work out of the box for this GPU. So I
Correct.
think some commands need to be added.
So
And for the inference part, I think one of your script command is wrong actually. There is the evil test no, it should be evil underscore test. It is evil hyphen test. Oh, because of that, it is
Correct, correct.
sometime it is
You're
not
right.
working.
Yeah,
can
correct.
you share that in Discord, Abhishek?
Yeah, I have already shared mentioning you yesterday.
And your training takes unusually long time. I think if you're using 5070, it should be less than half an hour, I think, with these many episodes. Or maybe max 1 hour.
Mm,
3 hours is slight.
yeah. So that in that computer, actually, I have two 5070 Ti GPU, each 16 GB each. So I will try to like run like parallelly to distribute the task among two GPUs. I will try the command and I will let you know in the
There is
Discord like
something called
how that works.
accelerate, something.
Yeah. So Accelerate, I read in their Lerobo repository, but I
Hmm.
could not find it to work. I need more time to study, and then
No,
maybe I can,
I
if I can
used it. It
complete one.
works.
Oh, okay,
On my two
okay.
machines, I've connected through a high-speed cable. They
Hmm.
work. They share the GPU. Yeah,
Okay. So if you can share the command in the Discord, so that would be great.
sure.
Okay.
So yeah, I think that's it. So
Thanks,
thank you.
Abhishek. Have you started up your company recently, or what is your vision with respect to it?
No, actually, I did started my company at 2017.
All
So
right.
I did my master's from a distance, like the working professional programs from BITS Pilani. Then last year I completed in 2025. Then I wanted to explore this robotics space.
Okay. Okay. Interesting. Very interesting, Abhishek. Thanks for the presentation.
Yeah. Thank you, sir, for all the knowledge.
Thank you. Thank you. Okay. Let's go ahead. Who is going to present next? Maybe Sri Harsha can present.
Yeah, yeah, I can present next. Let me share my screen. Mm,
Sir, will you be sharing this video later?
Yes, yes, yes. I'm recording it. I will be sharing with
Okay,
everyone.
thanks.
Can you see my screen?
Yes, yes, we can see it.
Okay,
Okay.
cool. Yeah, so sorry.
Can you just give me 1 minute? I'm getting a call
Sure,
from. Just one
sure.
minute. Yes, we can get started. Yes.
Okay. Yeah, thank you. Yeah, I'm Sri Harsha. I've been working on this one for the last 2 weeks. I got my set pretty early, so I started off right after Rajat's lecture. Um, so I mean, this is like just an introduction. I think we have all gone through this. I'll just skip these things. Um, Again, the same thing. What did I do and like what all basically like how the software components and stuff. I would also like skip this one because we've already been through this in others presentations. So this is my setup. Basically three cameras. One on the gripper, one on the top view, and one on the side view. Um, I've done a lot of what do you call experiments with like different episodes and positions and different types of cubes over the 2 weeks. What I found was that finally the 20 episodes one has consistently performed better than let's say 100 episodes or even like 180 episodes that I collected. Uh, they are not like completely very different from one episode to another. It's just like the cube was in different position and stuff. um so if you look at this grid, initially I tried like, okay, what if I put the cube here in the vertices of these edge of this matrix versus putting it on the edges versus putting it inside the squares. And I collected some data and then also collected some validation data. And then all that experiment, it didn't yield any better because the number of episodes were like 100 plus. So later, what I did was like I just collected 20 episodes where the cube was placed in these three squares, this and this and this, and also the cube is placed like in a straight position or as well as in a diagonal position, just to give that variation there. And typical parameters that I've used for the configuration, just the chunk size. I've tried 50, 100, different action steps. The video backends I tried with torch codec and stuff. Um, Batch size, I think again depends upon the VRAM that we have. I've varied it from 16 to 32 to 64, all the way till 256 also when I was using multi GPU thing, because the effective batch size can grow if you're using a multi GPU. But the last run that I did was on 5090 GPU in run pod. Let me actually start off with like playing the video to see how it is working. So this is a demonstration of all the in-domain distribution. So initially I'm just putting the box in straight. And then a couple of examples for diagonal when we put the box in like a like rotated version.
So this is a video which is actually taken, right? Like so it's like it's not stitched together from separate videos, but it's
No, no,
like
no. So there are two videos in there. One is the straight box video and the diagonal box video. That's all. But the video is continuous. Other than that, yeah, this is all continuous video.
cool.
Yeah. What I found was that in data, I think it is doing great. Out of data, it is completely zero. At least in my testing.
Mhm.
Yeah. Also, as we talked about this, right, like in machine learning, we would want to look at the validation loss to see if the model is overfitting or not. So I implemented that validation loss part. So in the episodes that I collected initially for that 100 episodes, I collected an extra 30 episodes for just for validation, and I was tracing like validation loss in the WNB as well. But like I said, the most simplest configuration and like 20 episodes is what worked the best. Anything complicated, it all just didn't work basically. So these are all my failed experiments I've tried. So first thing is like, okay, I thought like if you can train longer, like more number of steps with like more number of with higher batch size, that's better. So I was using this accelerate framework to train on that four RTX 600 Pro Blackwells. Each of them has like 96 GB VRAM. So each was like taking 64 or 128 per GPU batch size. But again, the output was not any better than just taking a simple 16 batch size on 5090. I tried these kind of settings as well, like varying the kale weight from 10 and 100, also turning off the VAE completely, doing this learning rate variations from like increasing the, after some checkpoints, like, after initially the learning rate is higher, but after some checkpoints, when it reaches around 60,000 steps, then I would stop and like reduce the learning rate so that it would generalize, but none of that helped. I tried the dropout variations as well. I also added like image transforms because it would be generally better, right? Like if we can do those, like these are the standard PyTorch out of the box image transforms. I think it's also directly supported in the Layerbot configuration. So it was adding like some jitter, some random color, or like some noise so that it is basically robust. But like I said, I tried all this. I didn't see any difference. Also checked with the validation loss, like added a script that will do the validation every few steps after training. It will do the validation and it will log it to the or WNB as well. Another thing that I found was that interestingly, the ResNet 18 backbone that we are using, it is this. They are using the same backbone for all the cameras. So I tried like how about using or instantiating different resonating backbones for each camera, like separate for different camera. But that also I didn't see any difference. And I was like doing the checkpointing like everyone, and then I pulled all the checkpoints. I was like going through starting from 20,000 steps checkpoint. I was like loading the model and trying to test it. I just found that consistently the more the number of steps, it is generally better. Um, but the lower checkpoints, even though when I traced it with the validation loss and tried to find a better fit, I didn't see any improvement there.
How did you implement the validation loss?
So validation laws, like there in the training itself, I added some more, like I added a custom script there itself, like made changes to the code base.
Mhm.
I have it. I have the link here. I basically took a fork of your modern robot learning Visual AI thing and made changes to that one in my repo, so I can create a pull request that
Yeah, yeah, yeah.
maybe if you're interested, you can.
For
Yeah.
sure. It's very useful.
So yeah, sure. When you say you're doing this validation loss, are you freezing the model when you're
Are
uh,
you? What? Sorry?
freezing the model?
Yes. Yes. It
Okay,
is
okay,
set to eval mode and zero grad. Yeah, the typical
okay, all
PyTorch
right.
stuff, right? When you
Yeah,
do
yeah,
the
okay,
validation. Yeah.
got it.
Yeah.
And about this ResNet being, uh, uh, are you saying that it's frozen? It's not trainable? Uh, is that
No, no,
what you're
no.
saying?
No, I
It
think
is
it is
trainable, right?
trainable. but
Yeah.
thing is, irrespective of your camera position, like let's say you're using two different cameras, right? For both the
Mhm.
cameras, whatever photos that you send it, right, you are using the same
Mhm.
single ResNet 18 backbone to train. Yeah, it might work, but I was just like curious, like what if we have a different model for different cameras separately? Maybe there is something that it can learn, but it didn't work. It didn't
But the
improve anything.
paper, yeah, but the
Yeah.
architecture they showed different ResNet models, right, for different camera
Yeah,
inputs.
yeah, I actually
Isn't that
read
what
it
they are
from that.
implementing?
Yeah, no, in the Lay Robot framework, if you go check there, they are not doing different
Oh,
ResNet
okay,
18s for different cameras. I
interesting.
think it was one of the tip that the author gave in that checklist that you shared right the other day. So
Yeah.
I think it was mentioned there. I think it like these ResNet
Okay,
18s are
okay,
being shared across the cameras. Yeah.
okay. I thought I
So
I, I
the
understood differently. I thought
uh,
it's the same architecture, and then it's going to get trained. Like when they even you can actually from PyTorch itself, they can pull ResNet with some pre-trained version, right? And then you can
Yeah,
train
yes,
it
it
on top
does.
of it.
Yeah,
That's what
that
I
is what it
understood.
does. Yeah, that is what it
Okay,
does. It actually pulls the pre-trained version and then it starts training from there. But the thing
but you're
is,
saying so same model for all different cameras.
all the cameras. That is what Lay Robot
Okay,
has
okay,
implemented. But the other is
okay.
suggested like use different models and let all of them train. Yeah, in
Got it.
parallel.
I missed that
Yeah.
detail there. Right.
Okay.
Interesting.
So moving on. So yeah, what I observed or my big takeaways is that I've tried so many times, like trying to increase the number of episodes, which would make sense, right? Generally, for
Yeah.
machine learning, you add data, it should actually improve. This is kind
Mm.
of like fundamental for transformers also, right? You add more data, it should work, but it is not, which was like very confusing for me. Yeah, but anyways, like the other one is that I found that in the run pod, when you try to, let's say, use 4090 or 5090 or 6000, or you use your own GPU, right? Different scripts have different torch version requirements and stuff. So it is kind of a bit complicated. So I added like a small Conda based script that I also shared in the Discord. Basically, that script works universally, like whether it is even in Mac or like Linux, irrespective of the GPU. You just run that script, it takes the right Conda environment and stuff. Um, Camera settings, again, I tried different resolutions, 180, 1080p, 720p, but there isn't any improvement in accuracy. Unless you go below 480p or something, I saw like there's a decline in accuracy, but otherwise not really different. If at all anything, it only increases the what do you call data size. So it will make your training more slower. Larger action chunk size is, I think, what helped. I tried doing different, like using 10, 20, 30, 40. I just found that the bigger, at least for prediction point, also during execution also, I think bigger the chunk sizes, the smoother it is, and more accurate it is. Also, someone was asking like how can we kind of speed up the whole training process? These are the key things that I found for training, or speeding up the training. One is that you have to keep an eye on the amount of time it takes to load the data, not just do the training process. So that loading part is all dependent on the number of workers you assign. So a good suggestion is like to sorry, this should be CPU. So number of cores in your set it to equal to the number of cores in your CPU. If you have like 16 cores, setting it to 16 usually helps on these run pods. Another one is like if you use the backend as torch codec, it is also pretty fast. And if you follow this script, it can install the torch codec and everything that you need without any issues. So that is another thing. The other training part is like, yeah, just like if you use a better GPU, it's just faster. And like relatively, if you use a smaller batch size, then also it goes faster. So if you are using 6000 Pro Blackwell, it has like 96 GB VRAM. You can have bigger batches, but it will correspondingly affect your speed. Another one is enabling AMP. Like if you enable this, it will do the automatic mixed precision. So which also I've noticed like speed improvement while training. Um, Moving on, the last one. I have shared that like whatever the data set and the policy that I've trained in the Hugging Face. I also have these three things that I made changes to, like adding a validation loss part, having different backbones for the camera, and also while training, like giving a nice visualization, like, okay, this is the step it is progressing and stuff. Also, I've shared in the Discord that Conda based, the script that will work in any environment, Mac, Linux, whatever GPU you use. Um, yeah, that's pretty much what I've done. Thank you so much.
Thank you, Surya. So this is very insightful. I'm trying to understand how number of episodes increase is actually making
Yeah,
performance worse. That is counterintuitive to me also at the moment.
yeah,
Maybe
Yeah,
in this,
I was going to share this paper. I'll share it. So I'm not sure if it's going to explain that, but that's where I ended up.
yeah,
But maybe Rajat, you
I
can take
think
a
I
look
think
at that as well.
it's very important for us to understand the intuition
Yeah.
behind this. Uh,
yeah,
help us later in all our experiments also.
Yeah,
yeah,
even in Sergey Levin's introduction, he talks about that, right? The causal
Yeah, yeah,
stuff.
yeah.
So the network learns to brake by looking at the brake light instead of looking at the person in front. So
Mhm.
that's the kind of thing.
Yeah, that is definitely very interesting. Yeah.
Yeah,
But yeah, the amount of variations you have done is also very, very nice.
right.
Yeah.
cool. Uh,
And
cool.
I
Yeah, sorry.
you have been quite active on Discord also, so thanks for that, I think.
Thank you.
Yeah.
Yeah, thanks,
Yes.
Shreya. Actually, you
Yes,
were
yes.
also good help.
Yeah.
Mhm.
Yes, Shreyas.
Yeah,
And
I
I
just
would also echo your act policy playbook, which you had shared, that really
right,
helped save the like some of the bugs which I received. So thank you for that.
right. Yeah, yeah. I just shared it because I already plowed through those issues, so I thought
Mm.
others would also
Oh,
face those similar
yeah,
issues,
it
right?
was
So
helpful,
yeah,
helpful.
yeah. Cool, cool. All right. Yeah, that's all. Thank you so
Thanks
much.
for the presentation. It was great.
Yeah, thank you.
Uh, okay, let's move ahead. Next one, who is ready with the presentation? I think some of you haven't got the kit yet. I think Vishaka has not got the kit yet. What about others? Yashwant, Sunil, and Pramod?
It is getting late for me. Can I leave for now?
Yeah, sure, sure. I think we are almost done because we are done with the presentations from everyone. Yeah, I'll just share a yeah, you're about to say something?
Sorry, I don't have a kit yet, so
Okay, okay, fine, fine. Yeah, yeah. People who want to leave can leave the room. I just want to share some projects from the GitHub which I have found interesting from that link which I shared previously. But yeah, first of all, thank you very much everyone for the PPTs. I think so many of you have done a fabulous job. And I think robotics is a field where collaboration is really helping us a lot. And I'm very impressed with the overall discussions on this group. I really enjoyed today. So thank you for working on the PPTs and keeping the Discord group active as well. So just to give you some motivation to work on with your kit, this is what people have come up with. And this is, I think, all these hackathons are maybe 2 or 3 days. They give you a small window to work on. So in 2 or 3 days, people have come up with something very cool. Uh, yeah, this is
Team Electrify from Tokyo.
I think they have done some pressing of electric switches or something with the S0-101. Let's
Space team, we're Team Electrify from Tokyo, Japan, and we're building robot electricians.
This I found to be specifically interesting because of the fine control which is required here to press the.
Yeah, and also the way that we set up cameras, that's also going to impact it. At the very beginning, I had this camera and the robot arm itself was blocking the view. That's like, okay, maybe I need to find some other spot.
This is a nice application. Some of these are not that interesting, so I'm not going through them. Yeah, this one is also not very interesting. This is cool. They added chopsticks on top of this. So this kind of gave me the idea that we can customize the gripper of our S0-101 to suit our needs. So it's also interesting.
Yeah, I just was typing that. Someone
Okay.
should work on modularizing the gripper.
Yeah.
Uh,
That's interesting that people are doing that, thinking in that direction.
yeah,
Yeah, this
different
is
tasks require a different way of handling it.
yeah. This also has some customization. This is something where they have actually I'll show this video, but it's very ambitious what they are trying to do. See how they have modified the gripper a little bit.
Yeah, interesting.
This I really like actually. It's nice. It's very different.
But these will be messy when you're doing.
Yeah. It will be messy, right? This one.
Yeah.
This is hard to do at home.
At home. Look at how much of plastic they have put.
Yeah. Then this one was nice. They used two arms for some coordination between the two arms. Yeah, and then apart from this. Yeah, this one is also.
Hi, we are Crash Team, and we all hate dirty dishes. So today's Spice Terminator is going to show how it can clean for us and how we can watch the cleaning from our office.
Our approach involved three key parts: data collection, training, and inference. We collected 70 samples of cleaning dishes and used them to fine-tune two models, NVIDIA GR00T and small VLA. The training process focused on teaching these models the nuances of dish cleaning through real-world examples. As you see on the screen, there are some training samples, and there is a real-life demonstration of GR00T VLA. Pretty cool, right? But there is more than that.
In our web-based platform, you can see a list of the connected devices.
Yeah, so this is I wanted to show this to all of you to see how people think in like different directions. So we can also, but it's good to see that I mean, two or three of you are actually thinking of modifying the policies, and that is good.